All right, for the last lesson for this chapter, we're going to take a look at higher derivatives. So, if y is equal to f of x is differentiable, its derivative, y prime, is called the first derivative of f. If y prime is differentiable, its derivative is called the second derivative of f. If the second derivative is differentiable, then its derivative is called the third derivative of f, going on and on and on and on for as many times as you can. The most common notations for higher order derivatives are as follows. The first derivative, or y prime, or f prime of x, or dy over dx, or dx of y. When we go to the second one, we're just adding an extra apostrophe, or we're doing to the 2 of y over dx to the 2. When we go to the third one, we add a third apostrophe, or the 3's. Once we get to a fourth one, then we just call it y of 4, or f 4 of x. After the third one, we stop using those apostrophes. Recall that the first derivative represents the instantaneous rate of change of a function. That is the slope of the tangent to the function at that point. The second derivative represents the rate at which the slope of the tangent to the function are changing as we move through the domain of the function. So we're actually going to be doing a second level slope. Now, it's really important to note, please make sure that you fully simplify before differentiating again. Now it says fully simplify the first derivative before differentiating to the second derivative, but just in all the derivatives, just fully simplify. It's going to make your life so much easier because it seems like you can just skip the steps, but once you get to further and further derivatives, it's going to just get absolutely insane. So, let's put this into practice. It says, determine every possible derivative for f of x is equal to x cubed minus 6x squared minus 5x plus 3. Well, let's start with the first one, f prime of x. And using my sum and difference rules and my power rules, I'm just going to take each term and I'm going to say that that's going to become 3x squared. It's going to become negative 12x, negative 5, and the constant is just gone. Once I get to the second derivative, then I'm taking the derivative of the first derivative. So now I'm just left with 6x minus 12. Once I get to the third one, I'm just taking the derivative of the second derivative, which is just going to give me 6. And because all I'm left with is a constant, once I get to the fourth one, then that's just going to give me 0. For example 2, it says determine the second derivative of f of x is equal to 5x squared plus the square root of x. Well, right away, I'm going to change that to f of x is equal to 5x squared plus x to the 1/2. That means that the first derivative is just going to give me 10x plus 1/2 of x to the negative 1/2. When I go to the second level, then that 10x is just going to become 10 when I take the derivative. And that 1/2 of x to the negative 1/2 is going to become negative 1 over 4 because of the 1/2 and the negative 1/2, x to the negative 3 over 2, or 10 minus 1 over 4x to the 3 over 2, or the square root of x cubed if you prefer. For example 3, it's asking for the third level derivative. So when I have y is equal to 4x to the 5 plus x cubed, then I'm going to take the first level, dy over dx, and I'm going to get 20x to the 4 plus 3x squared. When I take this down to the second level, I'm going to say d2y over dx squared is going to give me 80x to the 3 plus 6x. And then I take it down to that third level, d3y over dx3, and that's going to give me 240x squared plus 6. For example 4, it says determine the second differential of when x is equal to 1 for f of x is equal to 2 minus x squared to the power of 10. So, the first differential, we're going to use that chain rule. 10 is 2 minus x squared to the power of 9. And then just the differential of the inner, negative 2x. Or, to simplify this, I'm going to rewrite this as negative 20x and 2 minus x squared to the power of 9. Now, I'm going to use my product rule for the second level. So I have factor 1, I have factor 2. So I'm going to say that for the second level, that's going to equal factor 1, negative 20x, times derivative 2. Well, the derivative of that is going to be, using that chain rule, 9, 2 minus x squared to the power of 8 times negative 2x. Plus factor 2, which we said was 2 minus x to the power of 9 times negative 20. Now, we can fully simplify this, or because we're already at the level that we need, we can take this for when x is equal to 1. Which means I'm going to have negative 20 times 1 times 9 times 2 minus 1 squared times 8 times negative 2 times 1 plus 2 minus 1 squared times negative 20. Well, this is still just going to give me negative 20. In here, I'm going to have the 2 minus 1 squared is still just going to give me 1. 1 to the power of 8 is still just 1, which means that this entire multiplication isn't really going to make a difference. And I'm just going to have 9 times negative 2. I'm going to add to that, once again, that 2 minus 1 squared isn't really going to make much of a difference. Because that's still just going to wind up becoming 1, which isn't really going to change what the value is here. So I have negative 20 times 2, or 9 times negative 2 is negative 18, and then minus 20. Well, negative 20 times negative 18 is going to give me positive 360 minus 20, which is just going to leave me with 340. So F, second at 1, is just going to be 340.